Swarms of robo-spiders building 3D printed spacecraft in orbit could be closer than you think. Aerospace firms have penned a deal which will see them develop and test robots capable of manufacturing components in space. The first steps of the NASA-backed venture will see a machine launched into orbit to test if it can print and assemble trusses, the wireframe scaffold for supporting solar panels, antennae, sensors and all other parts of a working spacecraft. But the ultimate sci-fi vision of the project is a fleet of robots capable of printing huge structures, essentially knitting them together by 3D printing them. Called Spider Fab, the approach would enable space agencies to construct satellites and structures in space, which could enable far bigger spacecraft to be built in Earth orbit. The brains behind the clever spider bots, Washington-based Tethers Unlimited Incorporated, has completed a deal with commercial satellite firm Space Systems. It will see TUI's subsidiary firm Momentum fly its Translator technology on SSL's Dragonfly program. The Dragonfly program will test the construction of geostationary communication satellites in orbit as a precursor to even larger structures. Translator will fabricate lightweight beams in space which will form the support for solar panels, antennae and sensors. The Dragonfly program is a tremendous opportunity for us to demonstrate the readiness of in-space manufacturing technologies, said Dr. Rob Hoyt, CEO of firm Momentum. It is currently unknown when the trial will take place. Chief Technology Officer of SSL, Dr. Matteo Genna, added, the evolution of next-generation communication satellites and space systems depends on dramatic advances in technology and manufacturing processes. The advantage of such an in-space approach is scalability. In order for satellites to make it into orbit, they must fold inside the protective shell of a rocket to survive the heat and forces encountered as it leaves Earth's atmosphere. Building structures in orbit would mean that only the spider bots and their raw materials would need to squeeze into the rocket, clearing the way for kilometer-scale solar arrays the size of football pitches. Speaking about the technology in 2013, Dr. Hoyt said, on-orbit fabrication allows the material for these critical components to be launched in a very compact and durable form, such as spools of fiber or blocks of polymer, so they can fit into a smaller, less expensive launch vehicle. Once on orbit, the Spider Fab robotic fabrication systems will process the material to create extremely large structures that are optimized for the space environment. This radically different approach to building space systems will enable us to create antennas and arrays that are tens to hundreds of times larger than are possible now, providing higher power, higher bandwidth, higher resolution, and higher sensitivity for a wide range of space missions.